Download this code from codegive.com, link in the description below. OK, let's delve into the concept of AI's single point of failure, inspired by Rob Toews's observations, with a focus on how it manifests in real-world AI systems and potential code examples to illustrate the dangers. Understanding the core idea, AI's single point of failure. The single point of failure concept, borrowed from engineering and systems architecture, refers to a component in a system whose failure would render the entire system inoperable or severely compromised. Rob Toews, in his insightful writing, argues that AI systems often have such vulnerabilities, and they are frequently related to the data, the models, or the human expertise required to build and maintain them. The gist is this: we build complex AI systems, but if a critical element upon which the whole system depends collapses, everything falls apart. Why is this a problem? One fragility: AI systems can appear very robust during development and testing, but they are often susceptible to subtle changes in the environment, data distribution, or adversarial attacks. 2. Lack of resilience. If the single point of failure fails, there's often no graceful degradation. The system's performance doesn't merely decline slightly, it can plummet catastrophically. 3. Hidden dependencies. The dependencies in complex AI systems can be opaque. We might not realize that a seemingly minor data source or feature is absolutely critical until it disappears. 4. Data quality and bias. If the dataset used to train the AI model is biased, the AI model itself will perpetuate and amplify this bias, leading to discriminatory or unfair outcomes. If that dataset disappears, the AI cannot be improved. 5. Over-reliance on specific expertise. If the expert data scientists and AI engineers who designed and implemented the AI system leave the organization, maintaining and evolving the system becomes extremely difficult. Common single points of failure in AI systems. Here's a breakdown of common single points of failure, along with explanations and illustrative code snippets. 1. Training data set. Description. AI models are heavily reliant on the quality, quantity, and distribution of the training data. If the training data is biased, incomplete, or contains errors, the model will perform poorly or unfairly in real-world scenarios. Failure scenario. A company trains a facial recognition system using a dataset that primarily includes images of one demographic group. When deployed in the real world, the system performs poorly on individuals from other demographic groups. If the dataset becomes corrupted or unavailable, you cannot fix the bias. Code example, illustrative, demonstrating bias. Explanation. The biased dataset function creates a dataset where having a high qualification, represented by x0.5, significantly increases the probability of being hired. This simulates a bias in the data. The code then trains a logistic regression model on this biased data. The classification reports will reveal that the model learns to associate the qualification with the hiring outcome, even if there's no real causal relationship. If we invert the features, we can see how the model struggles to adapt. Vulnerability. If this biased training dataset is the sole source of data for the model, and that dataset is unavailable or corrupt, the model's performance will be significantly degraded. Furthermore, the bias embedded within the model will continue to propagate unless the model is retrained with a more representative dataset. 2. Data pipelines and feature engineering. Description. AI models often rely on complex data pipelines and feature engineering processes to transform raw data into a usable format. If these pipelines fail or become unreliable, the model's performance can suffer dramatically. Asterisk failure scenario asterisk a fraud detection system depends on real-time transaction data from a specific bank API. If the API becomes unavailable or changes its format without warning, the data pipeline breaks, and the fraud detection system is unable to function properly. The model remains frozen in its original state. Asterisk code example, illustrative, data pipeline failure. Explanation asterisk. Asterisk the load_data function simulates loading data from an external source. Asterisk the process_data function performs feature engineering, creating a high_value indicator based on the transaction amount. Asterisk the AI_model function simulates a downstream AI model that relies on the processed data. Asterisk vulnerability asterisk if the load_data function fails, example because the data file is missing or corrupted, the entire pipeline breaks down. The process_data function receives none, and the AI_model never gets executed. This means any dependency upon external data is a potential point of failure. Also, the process_data function creates features such as high_value and number_USA, and if the feature creation function fails, the AI model will also fail. 3. Model deployment and maintenance asterisk. Asterisk description asterisk deploying and maintaining AI models in production environments can be challenging. Models can degrade over time due to changes in data distribution, concept drift, or the discovery of new vulnerabilities. Asterisk failure scenario asterisk a spam filter model is deployed and performs well initially. However, spammers adapt their tactics over time, and the model becomes less effective at identifying spam. If there is no regular retraining process to incorporate new spam patterns, the model's performance will degrade, and more spam will reach users' inboxes. Asterisk code example, illustrative, model drift. Explanation asterisk. Asterisk the code demonstrates concept drift by training a model on data where the rule is y equals x 0.5. Asterisk then, it evaluates the model on new data where the rule has changed to y equals x 0.7. Asterisk the accuracy drops significantly, illustrating the impact of concept drift. Asterisk the model is retrained on the new data, which then improves the accuracy. Asterisk vulnerability asterisk if the model is not regularly monitored for concept drift and retrained with new data, its performance will degrade over time, potentially leading to inaccurate predictions and negative consequences. This is a single point of failure if there is no system for retraining the model. 4. External API dependencies asterisk. Asterisk description asterisk many AI systems rely on external APIs for data, processing power, or specific AI functionalities, example cloud-based machine translation, image recognition. Asterisk failure scenario asterisk an AI-powered customer support chatbot uses a third-party API for sentiment analysis. If the API experiences downtime or introduces breaking changes, the chatbot's ability to understand and respond appropriately to customer inquiries will be severely affected. Asterisk code example, illustrative, API failure. Explanation asterisk. Asterisk the analyze_sentiment function simulates a call to an external sentiment analysis API. Asterisk the chatbot_response function uses the sentiment analysis result to provide a relevant response to the user. Asterisk vulnerability asterisk if the API becomes unavailable or returns an error, the analyze_sentiment function returns none, and the chatbot is unable to provide a personalized response. This is a single point of failure. The entire chatbot fails because one of the dependencies failed. 5. Human expertise. Asterisk description asterisk AI systems often require specialized expertise for development, maintenance, and monitoring. Asterisk failure scenario asterisk a hospital develops an AI system to predict patient readmission rates, significantly improving resource allocation. However, the data scientists and AI engineers who built the system leave the hospital, and the remaining staff lack the expertise to maintain and update the system. Over time, the system's performance degrades, and it becomes less reliable. Asterisk mitigation asterisk ensure proper documentation, training, and knowledge transfer to prevent knowledge silos. Cross-train staff to handle essential tasks and document the decision-making process behind the AI system. Mitigating single points of failure in AI systems. Here's how to address these vulnerabilities and build more resilient AI systems. 1. Data redundancy and diversity asterisk. Asterisk multiple data sources asterisk use data from multiple independent sources to reduce the risk of a single source failing. Asterisk data augmentation asterisk create synthetic data to augment the training dataset and improve the model's robustness. Asterisk data validation and monitoring asterisk implement rigorous data validation and monitoring processes to detect and correct data errors or biases. 2. Modular design and fault tolerance asterisk. Asterisk microservices architecture asterisk break down complex AI systems into smaller, independent microservices that can be deployed and scaled independently. Asterisk error handling and fallback mechanisms asterisk implement robust error handling and fallback mechanisms to gracefully handle failures in individual components. For instance, if the API fails, have a simpler backup sentiment analysis. Asterisk circuit breakers asterisk use circuit breaker patterns to prevent cascading failures in distributed systems. If a component fails repeatedly, the circuit breaker will automatically prevent further requests to that component, allowing it to recover. 3. Model monitoring and retraining asterisk. Asterisk continuous monitoring asterisk monitor model performance in production to detect concept drift, data skew, or other anomalies. Asterisk automated retraining asterisk automate the model retraining process to incorporate new data and adapt to changing conditions. Asterisk A/B testing asterisk use A/B testing to compare the performance of different models and identify the best performing model for a given task. 4. API resilience asterisk. Asterisk rate limiting asterisk implement rate limiting to prevent abuse and ensure that APIs remain available to legitimate users. Asterisk caching asterisk use caching to reduce the load on APIs and improve response times. Asterisk fallback APIs asterisk have backup APIs available in case the primary API fails. Asterisk retry mechanisms asterisk implement retry mechanisms with exponential backoff to automatically retry failed API requests. 5. Human in the loop, HITL, systems asterisk. Asterisk human oversight asterisk incorporate human oversight into AI systems to handle situations where the model is uncertain or makes errors. Asterisk active learning asterisk use active learning to identify the most informative data points for human review and model retraining. 6. Documentation and knowledge transfer asterisk. Asterisk comprehensive documentation asterisk create detailed documentation of the AI system's architecture, data pipelines, models, and deployment processes. Asterisk knowledge sharing asterisk encourage knowledge sharing among team members to prevent knowledge silos and ensure that multiple people understand the system. Asterisk onboarding and training asterisk provide comprehensive onboarding and training for new team members to ensure that they have the skills and knowledge necessary to maintain and evolve the AI system. Key takeaways. Asterisk be aware of the single point of failure concept in the context of AI. Asterisk identify potential single points of failure in your AI systems, data, model, pipelines, dependencies, expertise. Asterisk implement mitigation strategies to reduce the risk of failure and improve the system's resilience. Asterisk continuously monitor your AI systems for performance degradation and unexpected behavior. Asterisk prioritize documentation and knowledge sharing to ensure that the AI system can be maintained and evolved over time. By proactively addressing these vulnerabilities, you can build more robust, reliable, and trustworthy AI systems that deliver lasting value. Good luck.